All right, we are picking up with 1-7 functions, part 2, and our objective is to determine whether a relation is a function. So last week we had some vocabulary, and this week we're just going to review and reiterate those words. So a function is part of a relation. So what is a relation? A relation is a set of ordered pairs. The domain is the input where the range is the output. Typically in math, we say the domain is the x and the range is the y. The domain is read left to right, the range is read up and down. A function is simply a relation in which there is a unique range value for every domain value. So what that means is for every x, there's only one y. It means that our x's cannot repeat. So in order to be a function, our x's cannot repeat. An easy way to do this is to graph our points and to see if it passes the vertical line test. So last time, we focused a lot on domain and range and making sure we could understand how to find those from a graph. What we're going to do now is take that same concept, but we're going to apply it with the idea of a function. So it says, at a car dealership, a salesman worked for 3 days. On the first day, he sold 5 cars. On the second day, he sold 3 cars. And on the third day, he sold 8 cars. Make a table showing the number of cars sold for each day. So we know on day 1, he sold 5. So right away, I'm looking at the day and the number of cars sold. So here it's day 1, 8 cars. Well, that doesn't match the description. So in my head, I'm basically saying, okay, that can't be. So let's mark or cross that off. And then in my head, I am also saying part B says day 5. Well, I was talking about on the first day, so it cannot be B. Letter C, day 1, so we're good there. Number of cars sold 2. Did he sell 2 cars on the first day? No. So lo and behold, that takes me to letter D. Number of cars sold, 1. Day, 5 cars. Number of cars sold, 3. Day 2. On the second day, he sold 3 cars. On the third, he sold 8. Day 3, 8 cars. So there we have it, all good and happy. Letter D. Alright, so determine whether x equals -2 represents a function. Well, the easiest way to do that is to graph it. So what we're going to do is graph this. So here's my x and y plane. X equals -2. So what that means is everywhere you have a y value, your x value is always -2. So when y is 0, -2. When y is 1, -2. And so on and so forth. So at x equals -2, this vertical line passes through more than one x value. So again, remember, vertical line test says, can I draw a vertical line and it only hit the graph once? If I drew a vertical line here, I hit the graph at every single point. So x equals -2 is not a function. Again, x equals -2 is not a function. Fails the vertical line test. Okay, determine whether the graph of 3x plus 2y is a function. So here's our graph. Plotting our x and y intercepts would plug 0 in for x, and you get y equals 6. So that's this point here. Conversely, plugging in 0 for y would give 3x equals 12. And then you'd get x equals 4. So that gives your y-intercept, or your x-intercept right here, because y is 0. So we've plotted our x and y intercepts, we connect them, and that's how we get our graph. Now the question becomes, does this pass the vertical line test? So drawing in vertical lines straight up and down. Do I ever hit that graph more than once? And the answer is no, I never hit it more than once. So yes, this is a function. So no, I never hit it more than once. Yes, this is a function. And then the last new part is finding function values. So why is this so important? Well, this is important because now we don't need to create a table. We can just find a value at a point. So what this is saying is if f of x is equal to the function 3x minus 4, what is f when x is 4? So what is the f of x value when f is 4? So what that means is we're going to take everywhere there's an x and replace it with a 4. So f of 4 equals 3 times 4 minus 4. So you get 12 minus 4 because you multiply your 3 and your 4 together, and you get 8. So f of 4 is equal to 8. So what that means is if I were to graph this point, we would have the point 4, 8 on my graph. If f of x equals 3x minus 4, what is f of negative 5 plus 6? So you plug negative 5 in for every x, and then we're going to add 6 to the end of the equation. So you'd get 3 times negative 5 minus 4 plus 6. Simplifying, you have negative 15 plus 2, or negative 13. So f of negative 5 plus 6 is equal to negative 13. Let's try one on our own. If f of x equals 2x plus 5, find f of 3. So 3 times 2 is 6. 6 plus 5 is 11. Answer D. F of negative 8. So again, same idea, plug in negative 8. Two times negative 8 is negative 16. Negative 16 plus 5 gives negative 11. So the rule doesn't change just because something's nonlinear. This is a quadratic, but we're going to apply the same rules. You're going to take that 3 and you're going to plug it in everywhere there is a t. You're going to use your calculator. You're going to multiply the squared, then multiply by 16. Then you're going to multiply 160 and 3. So you get 1,248 minus 480 plus 144. So again, check, make sure you get that on your calculator. And you get 912 when you subtract and add all three terms together. So once again, this is red. H of 3 is equal to 912. So the function h of t at x, or in this case, rather t, equals 3 is equal to 912. Let's stop there for today.